MCQ 17 will investigate the term constitutional isomers. This itself could be loosely referred to as structural isomers. We actually have a total of 3 subsets of constitutional isomers. Now the first of them, namely, will be our chain isomer. That's one of the easiest one to relate to. So branches and linear, they're considered to be as a form of chain isomer. Positional isomer over here will be useful if, let's say, we have functional groups such as alcohols and ketones and aldehydes that can actually move about. And the last one here is going to be on functional isomers. So some very common and popular one we're going to talk about are things like cycloalkane and alkene. They have the same molecular formula, different structural formula, and on top of that, the functionality of it has actually changed because cycloalkane is saturated and your alkene is considered to be unsaturated. So we're looking at correct statement. Let's just take a look at each of them first. So C4H10 here, we mentioned it has a total of 3 constitutional isomers. So C4H10 is actually considered to be as our butane. So take a look at part A here. So I just recommend going for full carbon skeleton. So C4H10, this is my first linear isomer. I can have a branch isomer here, which is a 2-methyl propane. So the next one here is we are considered about chain, but is there any possibility of position isomer? It's going to be unlikely. Again, position isomer is going to be useful if you have functional groups, all right, alcohols, carboxylic acids, aldehydes, and ketones. So functional isomer, we don't have any functional isomer of alkane. So for A itself, this is going to be incorrect. We only have a total of 2 constitutional isomers. For part B, we're going to deal with but1-ene as well as pen-1-ene. So already based off here, I'll just strike out B totally because even at the baseline of being an isomer, we're looking for objects, 2 of them when comparing, to have the same molecular formula. That's extremely important. That means the number of carbons and hydrogen, and in fact any of the elements and its count must be the same. And on top of that, inclusive of having a different structural isomer. So the structural itself formula of but1-ene as well as pen-1-ene is definitely different, but they do not have the same molecular formula. So for the case of B, it's off. For part C, constitutional isomers may differ in their chemical properties. Now I'll say that this is a true statement, particularly if we're looking at functional isomers. So as preface here, if we're going to take a look at the common one of cycloalkane as well as alkene, you can really see that chemically it's a little bit different. So going again with a but1-ene as comparing towards a cyclobutane, right? They satisfy the formula of same molecular formula but different structural formula. I'll say that for but1-ene is capable of electrophilic addition reaction. But for the case of cyclobutane, on this case here, the cycloalkene is only capable, at least in this case here, of free radical substitution reaction. So C seems to be quite a plausible answer now. And looking at part D here, constitutional isomer may have different molecular formula. Again, the word isomer, you must have the same molecular formula. So MCQ 17, the answer is C.